Hello everyone. So, let's look at one more problem. This is a transportation problem. So, let me read the question because the magnification is less. So, for this, your company is a major distributor of coffee in UAE. You can buy coffee from four roasters and distribute the coffee to three UAE cities. So the cities are Al Ain, Al Abu Dhabi, and Dubai. The monthly demand in these three cities is as follows. Okay, so 50, 120, and 180. So the cities are identified as A, B, C. So just remember that A, B, C are the notation for the city. In order to guarantee supply from four coffee roasters, you need to sign a monthly contract and pay a monthly fee. Now, when you sign a monthly contract and pay a monthly fee from the roaster, so this is a whether to have a contract or not is a decision variable. If you decide to sign a contract with the roaster, then you can use its supplies and pay for transportation cost of the coffee supplied from the roaster to the above three cities. The production capacity of each roaster and their monthly fee is as follows. So the production capacity is like this 75 150 like this, and then monthly fee is like this. So the transportation cost is also involved. So that is cost per ton. So $5 per ton, $3 per ton, and so on like this. Your company asks you to minimize the total monthly cost of coffee supply from four roasters and coffee distribution to three UAE cities. So the question also is given Xij represent transported coffee from roaster I to city J, and Yi to represent the selection of roaster, whether the roaster is selected or not. How many decision variables are needed for the formulation? So right away here we can see there are four roasters and three cities. So 4 into 3 there are already 12 variables in the case of this Xij. 12 plus 4 binary variables are needed. First of all, which roaster whether to select or not. So 12 plus 4 total answer will be 16. So the answer is 3, that is 16. So 30th question we solved. Next, move forward. One of the following is the correct formulation of the constraint representing the capacity of the roaster 3. Okay, so the capacity of roaster 3. So let us try to solve this thing. Now, let's go back to the question, and I'll share my video here. So what we are having is roaster 1, 2, 3, 4. Now we are having cities. Okay, so here selection or selection of roasters. So whether this roaster is selected or not. Okay, so then we have y1, y2, y3, and y4. So these are binary variables, 0 or 1. So if 0, then not selected. If 1, then we have selected that particular roster. Okay, so that is this selection problem. Then we are having cities, right? The cities, for simplicity, I'll call them city A, B, and C. So now, what is the variable we are using? X1A, X1B, X1C, X2A, X2B, and X2C, X3A, X3B, and X3C, and X4A, X4B, and X4C. So if I add horizontally, then what happens? So if I say, what is this number represents? It represents the uh, tons, amount of coffee going from roaster number 1 to city A. This is amount of coffee going from roaster number 1 to city B, and amount of coffee going from roaster number 1 to city C. So if I add the rows, then total amount of coffee going from roaster number 1 will be coming here. So now the question that is asked here is, sorry, I have to go back. So one of the following is the correct formulation of the constraint representing capacity of the roaster 3. So now I want to know what is the capacity of the roaster 3. Now capacity of the roaster 3 already given here in the question as 1 Let me check that. So capacity of roaster 3 monthly supply 175 tons is already given, but that 175 tons is subject to whether you are able to, whether you have selected that roaster or not. Okay, so capacity of roaster 3 is 175 Y3. So depending on the value, if Y3 is 0, then the capacity of roaster 3 automatically becomes 0. That means you are uh, not selecting that particular roaster. If Y3 is 1, then capacity becomes 175. So meanwhile, what is the supply? So 3A, 3B, 3C. If I add all these three, so X3A plus X3B plus X3C, this should be less than or equal to 175 Y3. Now, if I write it in standard format, X3A plus X3B plus X3C minus 175 Y3 should be less than or equal to 0. So, this is the constraint for the capacity of the roaster 3. Okay, so, let's look at the answers. So in this, if you look at the third answer, x3a plus x3b plus x3c minus 175y3 less than or equal to 0. So that is the answer. So the correct answer is the third one. Let's go to the next one. Now, question number 32. One of the following is the correct formulation for the coffee demand in Abu Dhabi. Okay. So let us see what is the coffee demand in Abu Dhabi. So, first of all, Abu Dhabi is which city? So we need to confirm that. So if I go back, okay, Abu Dhabi is designated as the city number B. Okay. So city B, what is the total demand? If I add all these things, what I will get? So I'll get X1B plus X2B plus X3B plus X4B. So this is the total supply reaching city B, and this has to be equal to the demand of the city B. Okay. So what is the demand? I think the demand is 120. Yeah, so here it is given 120 in the question. And of course, this should be greater than or equal to 120 because you can transport little more even because of your contracts and all. So it can be greater than or equal to 120. So that is the answer. So let's go here. Out of all the available answers, the B is the second one is the correct answer. Okay, so one of the following constraints will ensure that either roster 1 or roster 4 can be selected, but not both. Okay. So either 1 or 4. So immediately you can see the second one, y1 plus y4 less than or equal to 1. If both of them are there, then it will be 2 less than or equal to 1. That is wrong. So obviously B is the answer. Directly we can observe. So that is 33. Now come to 34. One of the following constraints will ensure that at least three roasters are needed for coffee distribution. Okay, so at least three. Yeah, so at least three means what? Three or more. So why? So if I take all these selection variables, y1 plus y2 plus y3 plus y4 should be at least greater than or equal to 3. So either it should be 3 or more than 3. So this one. So let's look at the answer. So here the answer is the third one. Y1 plus y2 plus y3 plus y4 greater than or equal to 3. So with this we have covered all the questions in the this particular exam, 34 questions. Some of them are not from linear programming. So at this stage we are not address them. And some of them are under linear programming that I try to address them. So that's it for this video. See you in the next video.